let's go ahead and look at part B of problem 1 from a previous exam, exam number 2 from ECE 207. This one, part B, we're wanting to find the differential equation that governs the dynamic behavior of this circuit. If you're looking at this, there's a lot of different ways you could maybe first see. You could say, oh, I want to write two mesh equations, an I1 and an I2. Or you might say, you know what, that gives me two equations in two unknowns. What if I looked at this particular node right here? Then if I did that, I just have the one node voltage relative to this reference node, and if I can see that, now all I have to really do is write KCL at that one node, and I just have to sum these three currents leaving that node to obtain the governing differential equation that I need. Let's start doing that. Let's say we're going to write KCL at node number 1. Then we have, let's call this I sub R sub 1, let's call this I sub L, and let's call this I sub R sub 2. And remember from Eli that we have V sub L is equal to L di sub L dt, or when we have inductors present in our circuit, if we want to write equations concerning those inductors, we probably want to write those in terms of the inductor current. Now to find, so now we have the relationship based on KCL. We have I sub R1 plus I sub L plus I sub R2 is equal to 0. What's remaining is simply to write those equations or that relationship, these variables, in terms of the inductor current. The middle one, I sub L, is already there, and we'll just change that to a lowercase I sub L. But now let's see what we have for I sub R sub 1. I sub R sub 1 is just the voltage at node 1 minus the source voltage over R sub 1. Then we have plus I sub L of t, and I sub R sub 2 is V sub 1 of t, the node voltage at node 1 divided by R sub 2, and that must equal 0. V sub S is given. I sub L is really the formula or the variable that we're wanting to solve or write our equation with respect to. And now what we need to do is realize that V sub 1 of t is the same as the voltage across that inductor, and from Eli we can write that voltage in terms of the inductor current, meaning everywhere we see V sub 1 of t, we can replace it with L di sub L dt as a function of time. Doing that, we can now say that we have L di sub L of t dt minus V sub S over R sub 1 plus I sub L of t plus L di sub L dt of t over R sub 2 is equal to 0. That's really the equation that governs the dynamic behavior of that circuit. The only thing that is unknown is I sub L of t in that expression, and we can then solve that first order differential equation if we need to. If we wanted to clean that up, we can simply multiply out the appropriate ratios, collect our terms associated with di sub L dt, and maybe isolate that on the left-hand side and push everything else onto the right-hand side and obtain the answer that we're looking for.